Awesome. Hey, everyone. I'm Taz Singh, and I'm the founder of Guild.io. I'm happy that you're joining us today for this authorization panel. It's probably one of my favorite parts of building a GraphQL server. I feel like it's one of those parts where it kind of follows the 90-90 rule of software development, which if you aren't familiar with that, is where you spent the first 90% of your time building a GraphQL server, and the last 10% is spent writing the authorization rules, which counts for the other 90% of the time writing a GraphQL server. Therefore, I couldn't be more thrilled to deep dive on this topic with you today, and I couldn't be happier to be joined by this group of experts on this topic. I'd like to start with Ankita from Treebo, Jonny from Unity Technologies, Sam, the co-founder at OSO, and Tanmai, the CEO of Hasura. After this, we're going to have a discussion room on this topic. So if you have any questions for today's panelists or just want to chat or hang out, feel free to join us in the discussion room, and we'd love to talk to you more there. But without further ado, let's dive into our first question, because I'm sure you'd love to hear from the panelists instead of hearing from me. So let's go around and talk about how each of you have worked with GraphQL authorization, just to kind of set the stage and provide some ideas for the panel, some topics of discussion we can talk about. So let's start with Ankita. So Ankita, can you describe how you work with GraphQL authorization?
Yeah, sure. Hi, everyone. To start with, we have two kinds of data. One that is publicly accessible, for example, hotel name, a location, email, contact. This is just a small piece of graph, and you can access this even if you're not authenticated. This other piece of data, like bookings done on a hotel, or you creating a booking, finance-related information of a hotel. To view this information, you should be authenticated, and you should have a required role on this particular hotel, right? So we first check all these role-based access. They are on the GraphQL layer. We check if you have a valid role in the system, and then we allow you to go to the GraphQL layer. Otherwise, we'll error out the entire operation in the context object itself, saying that you're not authorized. Also, to solve for insecure direct object reference, which means that you are a valid authenticated user and you are authorized to access the details of hotel A, but you're not authorized to access details of hotel B, which means that you have to check role for this user on a resource, right? These are all role-based access. And next comes this attribute-based access, which means a user has certain permissions to, let's say, take an example of, like we say, you don't have access to create a booking on a hotel. These kind of checks we have on GraphQL fields. The third type of authorization checks that we have in our system is data-based access checks, which means that you can refund an amount, but how much you can refund, it depends on some particular business logic. Now, this business logic is in the backend services. So on the GraphQL side, we handle role-based access checks and attribute-based access checks. This sort of high-level system that we have on authorization.
Awesome. Thank you so much, Ankita. And Jonny?
Absolutely. Yeah, so we kind of deal with authorization with a federation perspective as well. So we've kind of approached authorization from both the service level and also a gateway level within a federated system. So within Unity, basically we have a system where we've got the gateway, and then behind that sits services that some are controlled by us and some are not necessarily controlled by us, they're controlled by other teams. So for us with authorization, our main focus is consistency across all the services. And yeah, basically we've gone on a journey from doing authorization at the service level, so allowing the services to control the authorization themselves, but we've actually moved that to more the gateway level, and that basically gives us a lot more control in terms of the mechanism and how we update the auth mechanism, but also ensuring consistency across services. So in terms of what services need to worry about, they just need to worry about configuration, and that's pretty much it. As long as that configuration complies with the configuration definition, that's all they need to worry about. They don't need to worry about defining the mechanism at their level. It's all handled at the gateway. So in terms of, that's the angle where we come from. And yeah, happy to discuss that further.
Awesome. Thanks so much, Jonny. And I almost forgot to mention that Jonny actually has a talk on this later today. So I'm sure you'll do much more of a deep dive during your talk. But thanks so much. I guess moving on to Sam, would you like to describe how you've worked with GraphQL authorization?
Yeah, so at OSO, we work on an open source framework for authorization. So it's a library you add to your app. It's got a policy language, things like that. So we work with like many different people on authorization. And more we're seeing people who are trying to solve, the intersection of authorization and GraphQL. So, Wayfair is one of our, we've worked with them closely on their authorization system. They're using GraphQL. So we've done a lot of writing on, in general, best practices for authorization, like the different places you can apply it, the different kinds of models you have. And so it's been really interesting seeing how that stuff kind of slots into the GraphQL ecosystem and like the best ways to take those concepts and think about them in GraphQL land. I think, for me, like one of the, I think like kind of most interesting parts of authorization in GraphQL is it, because because you have this incredibly flexible ability to query any piece of data, it really requires you to be quite, rigorous with your authorization because whereas in the past you can maybe be, a little bit sloppier and just kind of protect an endpoint. Now you're like, actually, I need to make sure that every piece of data that a user could possibly request has been secured. And that really like forces you to kind of step up your game, which is, I think, fun.
That's awesome. And last but certainly not least, Tanmai.
Hey, thanks everybody. Great to be here. At Hasura, because we provide kind of GraphQL as a service, right, as a managed component or as a managed API. We have an authorization policy engine that's kind of built into Hasura, and kind of the model that we followed here, or the inspiration that we've taken, is fairly similar to another system, another well-known system that exists in the world, which has to deal with a very similar problem of there's lots of different models, and you can arbitrarily access anything, right? You can access any shape, any combination, any particular piece of, or even any computation on that piece of data. And what I'm referring to is a database. So databases for decades have had a very similar authorization problem, and mature databases have a system of authorization called RLS, which is row level security, which is a style of authorization that encompasses or that you can use to do everything from RBAC to ABAC to entity level access control, to even actually very almost business logic type authorization that Ankita was referring to earlier. So that's kind of the model or the policy engine that we follow. And what we've done is we've embedded that kind of a policy engine at the Hasura level itself to be able to specify rules like that at the model level. So from a GraphQL point of view, the way that we like to think about authorization or encourage users to think about authorization is to think of authorization policies attached to a model, right? So you have users and transactions, or users and orders, or whatever, right? You're thinking about authorization policies attached to a model, so that, but not at the resolver level or not at the schema level, at that kind of model level. So now what happens is that whenever that model is touched by a GraphQL query, so you do query user, or query article.user, or query order.user, right? Like however you end up accessing that user model, the same authorization policies are applied. So in a way, it's you're keeping it as kind of it's the least amount of redundancy, right? It's the least amount of duplication. You're making sure that the policies are kind of specified in one place, and if they change only in one place for that model. So that's roughly at a very high level, and we'll get into the details, I guess, as over the next few minutes. But that's kind of our approach.
Awesome. Thanks so much, Tanmai. And then just right off the rip there, I mean, there's so many different acronyms, so many different methods being thrown out. I mean, we got RBAC, which is role-based access control. We got ABAC, which is what attribute-based access control. PBAC, which is policy-based access control. There is GraphQL Federation, where you're kind of trying to align authorization within the services. There's kind of more provider models. There's kind of a hotel model that Ankita mentioned. I mean, this is sounding, you can kind of see why I think it's the 90-90 rule of GraphQL servers, where that last 10% of the time takes up 90% of your time, just kind of applying authorization on top. This is awesome. Well, anyway, kicking off with our next question. Something that is often kind of talked about in the GraphQL realm is how to provide efficiencies. And oftentimes in the context of GraphQL servers, that's often said to be the N+1 challenge when writing a GraphQL server. So essentially what they mean by that is for each kind of level, essentially that your GraphQL query or your GraphQL operation is going down, like that could be one more operation getting stacked on top of another when trying to resolve that operation. Arguably, layering on authorization on top of that data resolution makes it even less efficient, arguably, if you're just kind of using conventional logic. I'd love to hear about how you've tackled this and how you've tried to gain efficiency when writing your GraphQL servers with authorization or not. And I guess let's start, let's go in reverse. Let's start with Tanmai in this one.
When we kind of think about like the efficiency challenge or the N+1 challenge, it's exactly what I was talking about, right? Where you have this kind of this problem, I think, shows up in a few specific scenarios, right? So I'll just take those two scenarios. So the first scenario is when especially when you're fetching lists of items, right? So you're fetching through a list. And you want a common policy to be applied across the list of items. It's a little bit different from an access control ACL type model where you have a tuple that defines whether you have access to a resource or not, right? So you have you have an ID, like a hotel ID that Ankita was talking about, right? Hotel ID 1 or article ID 1, and you know whether a particular user of some role or whatever can access that particular entity, right? So you know very specifically that for a particular resource, whether you can access, whether this user can access it or not. But this problem it becomes more challenging when you're accessing a list, right? So you want to fetch a list of items. So how are you going to fetch a list of items, right? You're going to have to, you can't fetch 1 billion elements of a list and then filter out the 1 billion elements of the list at the application level, at the GraphQL level, to decide what data to send back, right? That's not going to be feasible. You're going to have to push down that authorization check to make sure that you're fetching the efficient list directly from your persistence layer, from your databases, right? So that's kind of understanding like that constraint has been important for us when we're thinking about efficiency, because when you're fetching a single object versus when you're fetching a list of items, and how you want to deal with also, you want to make sure that the authorization system is scaling well to both of those, right? And this is obvious in hindsight, but it was just an interesting point there. I think when we think about N+1 style situations, right, what really helps is that kind of model level specification of the authorization rules. So, when you're fetching a parent and a child and you're applying authorization, you have an authorization policy for the parent object and for the child object in a query. When the authorization rules are specified at the model level, it actually becomes quite easy to reason about efficiency because, for example, when Hasura is speaking to a data system where Hasura can compile it into a single, let's say, for example, a SQL query to fetch that data of the parent and the child, we're able to take the authorization policy rules and make it a part of the data fetch itself, and even do the analysis to remove redundant rules. Right, like I'll take a very simple example. You're fetching articles and authors, right? So you're fetching article.title, article.id, and then you're also doing article.author.id, article.author.name, article.author.email. Now, let's say the constraints for you to access these objects, right, are dependent, meaning that I can only access an article if I'm the author, right? But then you're also accessing the article's author, which is the same check, right? It's the same check that you're doing for both of them. So this is redundant because the act of fetching that data itself is the act of authorization, right? And in this case, it's redundant, right? So then we're able to kind of do static analysis and remove it and make it one fetch, right? So that becomes fairly easy. Now this obviously ends up solving the N+1 problem anyway. This also makes the authorization better. And you don't even need 2 calls, so not even N+1, but not even 2, and it becomes the same check. So that kind of model level specification of policies and integrating that with a predicate pushdown and integrating that deeply with the data fetch, like the data fetching and the authorization in my mind, are quite closely coupled, right? And you want them to be close for performance reasons. So that's kind of been a thing that's helped. Yeah.
Awesome. I feel like we could talk for ages on this just alone, Tanmai. Every time I speak to you, that like this panel and last year's panel, I just want to talk to you so much more. But anyway, I'd love to talk more with Sam. So Sam, can you talk about how you've gained efficiencies when building GraphQL servers with authorization?
Yeah, I mean, I think Tanmai hit on the main thing, right? Like it's all about that ability to evaluate the authorization rules at that database layer for like list indexes. That's just the one where it comes up all the time. So yeah, so we have like a similar concept. We have the idea, the ability to kind of take your authorization policies, push them down into like SQL filters. So yeah, whether you're using GraphQL or anything else, like you get to leverage those benefits. And that's that's really that is like where the biggest one comes from. I mean, yeah, beyond just being an efficiency thing, it's such like a wonderful kind of like safety blanket for your like apps as well. It's kind of the kind of by doing it that like data layer, you've sort of already like applied this like kind of read-only filter effectively to like all the data. Like you just anything that the user is going to pull from the database, you kind of have that pre-filter applied of like, oh, it's going to be authorized. And that just gives you like, both that performance efficiency wins of like, as you say, not fetching a billion rows, but also just that kind of comfort in knowing that the data you pull is going to be the data the user can see.
Yep, that makes a lot of sense. You're both attaining essentially some sort of efficiency gain, but you're also minimizing the risk of basic data leakage across different operations. So it makes a ton of sense. Awesome, Jonny.
Yes, this is actually for me it's a really interesting chat because it's really highlighting different situations, in my opinion, kind of require different solutions. So for us, like one of the key differences is we don't have a database. We don't have access to the database. The services that in our federation system talk to, they are not necessarily controlled by us. So it kind of presents a whole different authorization problem. How do we kind of have that overall catch-all sort of for authorization that everyone can coherently use across the organization? So for us, we really thought about this and we kind of made the decision that for this catch-all in this federation system, it made a lot of sense to go to the gateway. So kind of the opposite of what Tanmai was saying. And basically the reason why we did that was basically for two reasons. One is we actually have like an endpoint which does authorization and that live right next to our gateway. So performance reasons, it just made sense to just talk to that directly. And basically services don't need to reach out, across the world to talk to this endpoint. It's like this performance gains are immediate there. The other one is just consistency. So, I kind of alluded to it earlier, like services, all they need to care about is configuration and that's it. They don't need to worry about the mechanisms. So for teams onboarding with us, they don't need to worry about having this SDK written for Rust or Node.js for whatever they're using. They just define the configuration in their GraphQL schema, and our gateway understands that and is able to apply the auth mechanism as the sort of the catch-all blanket. So it's kind of like completely opposite to what Tanmai was saying, but for me it kind of highlights maybe it's situational for what the solution you choose. So.
If I may ask a question to Jonny, Taz, I'm very curious. Could I?
Yes.
All right, we'll go for it. Okay. So, John, when the authorization that you're doing at the gateway, is that more about kind of authorization of like the schema of like what what entities of the schema you can fetch? What I mean is like, we call it role-based schemas, for example, right? Like it's schema visibility in a sense, right? It's like certain aspects of the schema are visible to you and certain aspects are not. Is that what the authorization covers? And does the authorization also cover things like, what specific entities are of a user, right? Like user ID 1 is available, user ID 2 is available. I'm guessing that kind of data fetch thing is done by the service itself. And the gateway here is doing more of a schema visibility thing, but that's what it sounded like. But what does your authorization look like at the GraphQL gateway layer?
Yeah, absolutely. You're absolutely right with the data fetching is handled by the service. and we use an RBAC system. So our authorization is basically on the GraphQL type. That is essentially, our the field that we're trying to protect in the type. The entity is the type, and we strongly correlate that because it just we have a convention-based approach, and that allows us to just define really coherent and consistent authorization, because you know the entity, like you alluded to, the field you want to protect. So from there we can apply that to our RBAC system.
Makes sense.
And like it's not just us. So this RBAC system, it's not just us using, it's actually other people using it as well. So it's super flexible in the way that's done.
Yeah, that's very interesting, and yeah, I'm looking forward to learning more in your talk later as well, Jonny. I'm sure you'll deep dive on that more, because I'm also like have a lot of questions as well in terms of like how it all manifests. But I guess something you touched on there, which is configuration, and like the most efficient thing you can do is convention. Failing that, configuration. Failing that, the least efficient thing you can do is arguably customization, right? And so a custom approach everywhere is arguably the least efficient. So I like your convention first approach, and yeah, I'm looking forward to learning more about that. Ankita, would you like to tell us more about how you're achieving efficiencies with GraphQL authorization?
Yeah, hi. So more of what Tanmai already covered is I'd like to give an example to understand more. So let's say there's one front desk manager of a hotel. He's trying to fetch details of users of, he's trying to fetch details of a user in a booking. But he's not authorized to view, let's say, the preferences of a user. He's not authorized to view more details about a user, but he's still trying to and one booking has, let's say, 25 users. Okay, so you will get list of 25 users, but he's not authorized to view some particular fields in this query. Now one way to go about is you have authorization checks on the resolver level, which means you check if this particular role has this privilege, has this permission to view this particular data, and then you do it at a resolver level, which means you are going to do these checks 25 times for every user. But what we have done is we have moved this check on the data source level, as in where you are actually, where you are, let's say, fetching information about this user from downstream services. So that means you are going to call this only once. You're going to check only once for this user, right? If you have batching in place. Now again, from downstream services, even it's not that from even I agree with Tanmai that on the persistence layer, on the database side, you should not be fetching 1 million rows even though you don't have access to. So we are yet to implement this properly, but we do have checks at batching level and sort of preventing this n+1 problem.
Okay, awesome, very cool. Yeah, there's a myriad of so many different approaches. I'm really enjoying learning from all of you. This is so awesome. Well, cool. Well, I guess we talked a little bit about how we went about implementing authorization and how you work with authorization. I'm curious, like how does like some sort of unauthorized access manifest in your GraphQL server? Like essentially, how do you know that someone's like is basically unauthorized to do something? Do you, like essentially, is your schema entirely nullable, for example, where if you don't have access to something, it just returns a null? Or do you throw a GraphQL error if something is unauthorized? Do you then error out the entire operation? Or do you error out with like a path to essentially where you have unauthorized access? I'd love to learn more about kind of how you're handling this on the server level. And I guess why not start with Jonny?
Yeah, absolutely. Yeah, so just a bit of context actually. So our teams, we've been going for about just 2 years now. I joined about a year and a bit ago. So we're in the process of scaling up and developing all our conventions. And one of the approaches we've kind of started off with is just, keeping it simple. And we treat a request as if a user of the request doesn't have full permissions to access all the data, the request will fail. And that's kind of like an early decision we've taken initially, just to kind of keep things simple. And basically we expose a top level GraphQL error. This GraphQL error has like a really strong convention for the data it's exposing, so people can look for particular codes to indicate that it's an authorization error and so on, and kind of make decisions in the UI based on that. we do appreciate that, you can take a more partial approach and a nullable approach. So actually, I'd love to hear from, the others on what they think about that approach.
Yeah, I can see Sam nodding a lot with that approach. Let's go over to Sam.
It's because I love this topic. It's a great one. I think there's like an interesting mix. Because there's so many different kinds of authorization you can do. We've heard a couple, right, where you do authorization like at the data layer, and it sort of filters out the data, and there's like authorization at the kind of more of the schema layer, like which pieces are you allowed to see. And I think there's kind of a couple of like really key elements for it, and a lot of it, I think, for me resolves around like the user experience at the end of the day, or even the developer experience. So I think for me, it's like if you're applying that kind of row level read filter sort of authorization, then that's great. It kind of filters out the data you can't see, and you don't even know what doesn't exist, which I think can be really important when even knowing that something exists is actually potentially like an authorization hole. Like you don't want someone to try and probe for data and find out if it exists, whether they get an error or not. So kind of applying that, like if you can't read it, you don't even get to know it exists, is great. But I think as soon as you're into the world of like, a user's tried to do something that they're not permitted, they'd never be permitted to do, they can never see this field on the schema, then it really does make sense to return that as an error, because you need to kind of get into that world of like, how am I going to handle that? What, it's potentially even a bug in the, in the app that it was requesting in the first place. Like, could we avoid even letting the user kind of go down that path in the first place? I think we might touch on that later. So it's kind of like, there's a lot of different sort of branching paths you kind of get into in this world, and you sort of really need to think around the, what does it mean if the user can or cannot do that thing? Is it, do we want to be returning like a nice, healthy, and a good error? It's like, hey, you just try to go and, delete this thing through a mutation. Like, you're not allowed to do that. Maybe you need to go and talk to your like system admin or something to get that permission. That's like one scenario you might want to try and achieve. On the other hand, yeah, you might just want to be like, for this user, that piece of data should just like never exist, and they should never see it, and let's just treat it that way.
I think just kind of adding to what Sam was saying, right? I think it's for us, when we think about the how we hide things in the schema and in the data, right? Like we've been thinking of it as like role-based schemas. So you create an application role or an application scope, and they have a schema that only they can see. So they have a subset of the entire schema, but they only get to see that part of the schema that they can access, right? So if you're in an application, you have an application role which represents the role of somebody logged in and they're a user, somebody logged in and they're a manager. And that context now of this user on the application is a user or a manager or an admin or front desk manager, right? For example, what Ankita said. And they have a particular subset of the full GraphQL schema that they're able to access. So the rest of the schema doesn't even exist for them. And then similar to that on the data side, like a business logic kind of authorization error is part of the schema itself, or has nice error code so that people understand what's happening. And from a data level, it's kind of like the 404 thing that Sam was talking about, right? You don't even want to tell them that this data exists. So you make you fetch a list of items. That list is itself scoped to only what you can access. So if you can't access anything, you get an empty list, or you get a null if you're accessing a single element. So that way you're not leaking information about like, does this data exist or not, or do you not have access to it? It's like you're going to a GitHub repo that you don't have access to, right? You'll see a 404. You won't get any information about whether this repository even actually exists or not. You're just seeing a 404. So that's kind of on the data side, that's something that's worked. But yeah, that's kind of how we've been thinking about like this visibility aspect.
Just like one little subtlety I want to add to that as well. If you think about it, it's like, yeah, you go and visit the page, you try and read the repository, it doesn't exist, but you might even just try and like go and make a mutation directly to it, go and try and push to it. Yep. But that scenario, you also need to say, I don't know, you're pushing something that doesn't exist. So it's like, it's not even just as simple as like looking for the read as well. Like some of this mutation, well, it's this stuff.
I don't know what you're talking about. That thing never existed. What are you on about? Yeah. Ankita, we'd love to hear from you.
Yeah. We follow this approach of having nullable fields by default. We'll make it non-null only if you cannot think of a use case, any probable use case that this field cannot be like it will always have value. Then only it is. Then only we put that exclamation mark that okay, in all the front end, let's say we have 4 to 5 front end clients that are talking to your GraphQL layer. For some reason your database is down, something, the entire GraphQL will start giving you errors just because that exclamation mark. So we actually design it in a way that this particular field should be non-null only if you cannot think of a use case. Like for authorization, we'll for all these fields, field will we'll send null for that particular field and give you an error response that you're not authorized, and the path, and on the front end client. So it's like, like Tanmay mentioned, that it's not that we don't have this value in the database, it's just that we cannot give it to you because you don't have access to this field, right? So this is how, like it's not that this particular field is not there in the database. Yeah, sort of. Actually, I have one question for Tanmay, if you may. You were mentioning about role-based schemas. How do you, like, what are role-based schemas? How do you do that?
So it's kind of again specified at the model level, right? Like each model, you've attached this thing called, each model might have multiple roles, right? And that role says whether this model is accessible, and what fields are accessible, right? Like for example, I create a user model. Now for the user model, for in your example, like you have the front desk manager, right? So front desk manager can see user.id, user.name, and not user.email, right? So user.name, not user.email, not user.address, none of that, right? So so now that we have this information, we will now compose the GraphQL schema from this information. So the user never specifies a GraphQL schema explicitly. We derive the GraphQL schema from this model information. So now when we try to derive the GraphQL schema, when you're looking at the user model, and you're seeing that the role is front desk manager. So when you try to run an introspection query with the role front desk manager, right? If your authorization claim, your JWT token contains a role called front desk manager, or there's a header that says I'm a front desk manager, that introspection query itself will show you only the user, like any resolver that returns a user is only going to return user ID and name, right? It's not going to return email. And whether you're fetching user from the top level or whether you're doing like booking.user, even if you do booking.user, you're only going to get ID and name. Booking.user will also not give you ID, name, email, whatever, right? So that's how we think about like role or scope based schemas, whatever you want to call it.
Good, awesome, thanks.
I'm just happy you didn't call it optical lenses for GraphQL schemas, Tanmai. I think a Haskell developer understood that joke. Anyway, I guess moving on to another question. We talked a lot about how these errors manifest from the server side, but I mean, of course, one of the main benefits of using GraphQL is for the client. Now, I'm kind of curious how do GraphQL clients work with authorization and also unauthorized states? Like for example, in the case of you having nullable fields, how do you offer any sort of advice to your clients for dealing with that? In case of throwing an error, do you offer any advice for the clients dealing with that? And I guess along with the same question, in the circumstance that you're an admin and you can only do certain admin actions, like how is your front end or your client aware of non-admin actions and you cannot perform that admin action in order to not show that button? Are you kind of duplicating authorization now? Yeah, kind of essentially that realm, of questions. I guess the only person we haven't started with yet is Sam. So Sam, would you like to take it away?
Sure. Yeah. So our favorite pattern for this kind of thing is to actually like extend your data models to include a field that contains, say, the permissions that the user has on that particular record, that particular piece of data. And the reason that's like really nice is, as you said, depending on the role you have, maybe you have read permission on a particular thing, maybe you have delete permission, edit permission, whatever it is. So you can kind of like return that list of permissions back to say the front end. And given that, it's like very easy now to customize your UI around what the user can do. right? So you go and fetch your list of things for the dashboard, you display the dashboard, and you kind of have, maybe the delete button grayed out if it's not something the user can do. The logic for that is you can like wrap this up in like a React component, like really simply. Like if the delete permission is in that thing, then like show it or not. And that what that kind of allows you to do, which is really nice, is you don't end up duplicating like any logic anywhere. You just have that one simple check. You go and add a new rule, you go and change the permissions, whatever you do, like the front end's going to be pretty happy with it. So yeah, that's kind of like that's like our favorite pattern to apply this. Just do a little bit of a pitch for Oso here. Like, we kind of have like APIs that allow you to say like, what are all the things are users allowed to do on this particular piece of data? So it's just, that's kind of like the work is done for you, basically.
Awesome. Ankita?
Yeah. So what we have is, let's say we have one microservice roles and privileges. Now this what we do from front end, we make one call to the service and send role that please send me all the privileges that this role has. And on the front end, you have a privilege to create a booking. So we'll enable that button for you. So you can click it from the front end. And if you don't have that particular privilege, we'll gray it out. Right. Similarly for other things as well. But this is on the UI side. But now you go to Postman and you hit create booking, even if you're not authorized to some other role, you do a curl request on GraphQL, and you have prevented front-end access checks, but you're directly accessing GraphQL. So these privilege checks should be on your GraphQL server as well. Like I mentioned earlier, that these should be on the data sources, right? We again check that if you are actually authorized to create a booking. So in a way, on the front end side, we make one API call, but on the back end, on the GraphQL side, we also check again that you really have permission to do this. And if you're not, doing curl command or doing something else, this is how it is. And the second question was, let's say you're doing some mutation and you're not authorized to do it, we straightforward show it to the user, you're not authorized to perform this action, but there is some data in the list that we don't even want to tell user that this particular piece exists. We don't display that section.
Yeah, thanks for bringing that one up, because I really want to emphasize how important that point is. Client-side checks are like never sufficient to do authorization. It's a thing which can make your user experience nicer, to like inform the user what they can do, but you always have to do that back-end check as well. So yeah, it's a really important point. Thanks for bringing that one up.
Yeah, and I also personally enjoyed how you focus on consistency there. I mean, you'd hate for the front end to show you that you have an action allowed and then the back end to reject it, or vice versa in some way. So I really like that you focus on consistency there as well. Tanmai.
I think to a degree, the one of the things that we talked about earlier, like this idea of role-based schemas, it kind of automatically, when you introspect the schema and it only gives you a certain subset of mutations or queries that you can do, you automatically have a sense of, what's even allowed. Like, what is my GraphQL API is an accurate reflection of, what set of actions I can do, right, on the application itself. So that has a little bit of information built in. But I think to kind of both Sam and Ankita's points, right, like there is Hasura metadata that's available that any application can also use and embed, so that they understand what are the scope, like what are the privileges that they have, and what is the scope that per model or per role, what is allowed, what is disallowed, and how is it allowed or disallowed, right? But the nice thing is, because it's declarative kind of configuration, right, these policies, you can make an API call to fetch it dynamically, but you can also embed it as a static asset and use that in the code, in kind of like your front end code, to see what those authorization rules for accessing things or not are. You have to be a little bit careful with it because you don't want to leak information. So how you embed that, etc., and what information you extract from it is important. But it helps you get that consistency between the front and the back end. And like again, there's many different ways of doing it, right? It could be something provided by your authorization system, or it could be, even if it's a entitlements model that you maintain somewhere, right? You maintain a central database of roles and entitlements and what privileges and actions they have, and you use that as a source of truth to enable or disable buttons, or enable or disable UI components as well, right? Of course, using that in the actual authorization check on the backend itself, but also on the front end. So that those sound like really good ideas to me too.
Awesome. And Jonny?
Yeah, so kind of answering a question actually. So kind of one approach we've also taken is we really like the idea of just lots documentation driven stuff, and be able to, much like some cloud providers, they tell you, straight away what permissions you've got from a documentation perspective in order to access this field. So one approach we've taken is actually using directives. So we define directives to define what permissions are required for this field. And kind of like on that note of like permission evolution and kind of role evolution, one for Tanmai quickly actually. With schema evolution, does that coincide with like role-based evolution as well? So if you're adding or removing roles to the schema and that sort of thing?
Yeah, you'd have to factor that in. So you'd have to factor in how kind of the like how you evolve the schema has to be done carefully, right? Because it's going to it's going to be role-based schema evolution as well, right? So yeah, generally the idea that you're kind of working at the model level helps, right? Because you don't actually care about the GraphQL schema. You don't care about what the GraphQL schema looks like. You just care about like a model and whether that model is exposed true, false, or whether partially exposed, right? And then the schema is kind of composed automatically by putting the models, and any models are related together anyway. So that's a layer of like simplicity. But yeah, you have to think about that too.
Awesome. And actually that ends the time that we have. So thank you all so much for being a part of the panel. I learned a lot. Now I won't spend 90% of my time writing authorization rules anymore because of everything that I learned from this panel. And for all of you out there watching, if you enjoyed this, we have a discussion room to follow where you have all of these lovely panelists there as well. And make sure that you attend Jonny's talk and check out everyone else's lovely projects as well. Until next time, we'll see you then. Bye.